Welcome to AI 101. Today, we're starting with a little industry secret that completely shifted how I think about AI coding assistants. That highly capable AI everyone is calling an agent, it literally cannot do a single thing. It cannot run a command in your terminal, it cannot open a file on your laptop, and it cannot even remember what you said to it a minute ago.
Laughs. It really does sound like the world's most useless assistant when you put it like that. But it is entirely true. When you watch an AI magically debug your local environment or write a complex test suite and watch it pass, the AI model itself isn't actually executing any of that. The model is completely trapped. We call this mental model the brain in a jar.
Exactly. And today, we are going to break down why that mental model is the single most important concept you need if you want to truly understand how AI coding tools work under the hood. Once you grasp this separation between the brain and everything else, all the bizarre behaviors you see when using these tools, why they succeed, and why they sometimes fail spectacularly, will finally start to make perfect sense.
It really is the foundational concept for this entire series. If you don't understand the jar, you can't understand the agent. So, no fluff, no delays. Let's just dive right into the jar and figure out what is actually going on. Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself. To understand the brain in a jar, we have to talk about what a large language model, or LLM, actually is. At its absolute core, an LLM is just a pure mathematical function. You give it text as an input, and it gives you text as an output. That is the entire transaction.
Right. It is a completely stateless brain. When we say stateless, we mean it has absolutely no persistent memory of its own. It forgets everything about you, your code, and your project the very millisecond it finishes generating its reply. When you send your next message, it is waking up brand new, with a complete case of amnesia.
It also has no hands. A raw LLM cannot ping an API, it cannot read a file system, and it certainly cannot spin up a Docker container. It is a brilliant, highly educated reasoner that is completely sealed off from the outside world. It can think, and it can speak, but it cannot act on its own.
Which always brings up the obvious question. If the brain has no hands and no memory, how is it navigating my codebase? How is it finding a bug in a file it's supposedly unable to open? And how is it running my test suite to verify the fix?
That brings us to the second half of the equation. Everything that we consider agentic, the ability to explore, to plan, to run things, lives entirely outside the language model. It lives in a wrapper program that we call the harness.
The harness is the unsung hero of the AI revolution. When you are using tools like Claude Code, Codex, Copilot CLI, or open source tools like Aider, you are not just talking to a model. You are talking to a harness that is wrapped around a model. The model is just the brain. The harness is the program driving it.
And this harness is just standard software. It's written in Python or TypeScript or Rust. It doesn't use neural networks to run commands. It uses standard system libraries, just like any other program on your computer. It acts as the ultimate middleman between your operating system and the LLM.
Exactly. The brain in the jar can't do anything on its own, so the harness provides the infrastructure. It takes the brilliant, isolated reasoning of the LLM and translates it into actual, physical changes on your machine.
If the model is the brain, then the harness is the body. And this body provides four critical things. First, it provides the hands. When the model decides it wants to see a file, it outputs text requesting it. The harness intercepts that text, actually opens the file, reads it, and feeds it back to the brain.
Second, the harness provides the memory. Because the brain forgets everything after every single turn, the harness has to maintain a running log of the entire conversation. The harness is the one keeping the receipts and managing the history.
Third, it provides the nervous system. This is the continuous loop that keeps the whole operation moving. The harness is what decides to send a prompt, wait for a response, parse the output, run the requested tool, and then automatically send the results back to the brain.
And fourth, it provides the rulebook. The harness contains all the hidden instructions and guardrails. It tells the brain how to behave. So when you buy an AI coding tool, you're acquiring a specific harness: the hands, memory, loop, and rules. That is the software wrapped around the jar. Let's double-click on that memory aspect, because it is the weirdest part of how this works. We said earlier that the brain forgets everything. So how do you have a 30-minute debugging conversation with it? The answer is that the context is the brain's whole world.
Chuckles. It really is a Groundhog Day situation. Each and every turn, the harness takes the entire transcript of your conversation so far, your first prompt, the model's first answer, the tool results, your next prompt, and sends the whole thing back to the brain in one massive text blob.
The model wakes up, reads the entire history in a fraction of a second, gets caught up on the plot, decides on one next action, outputs that action, and then instantly dies again. The continuity you feel when chatting with an AI is a complete illusion. The transcript itself is the memory.
This is why context windows matter so much, and why things slow down when you have a long chat. The harness has to keep stuffing that ever-growing transcript into the jar. As of 2026, and still evolving, managing that context is one of the hardest engineering challenges in building these tools. We're going to dive deep into that loop in episode 2, but for now, just remember, the brain only knows what the harness shows it.
I love using the sealed room analogy for this. Imagine you have a brilliant military strategist, but they are permanently locked inside a windowless, sealed room. They have no cameras, no internet, and no doors. All they have is a slot under the door to pass notes.
You, standing outside the room, are the harness. The strategist slides a note under the door that says, "Send a scout to the northern ridge." They can't send the scout. They don't even know if it's raining outside. They just wrote a note.
Right. So you, the harness, read the note. You walk over, tap the scout on the shoulder, send them to the ridge, wait for them to come back with a report. Write that report down on a piece of paper and slide it back under the door to the strategist.
The strategist reads the report, thinks for a second, and slides a new note out. "Move the cavalry." The strategist never leaves the room, never touches a horse, and only ever sees the world through the pieces of paper you slide under that door. That is exactly how an LLM interacts with your computer through tools like MCP or local APIs.
This separation is why you can actually swap the brain but keep the body. Many modern coding harnesses let you choose your model. You can use a tool like Claude Code or Aider, but switch the underlying brain from an Anthropic model to an OpenAI model or a local model.
When you do that, the hands, the memory, the loop, and the rulebook all stay exactly the same. The only thing that changes is the reasoning engine locked inside the room. And this is where it gets fascinating, because the exact same tool can feel completely different.
Oh, absolutely. With one model, the tool might feel brilliant, anticipating your needs and writing flawless code. Swap the brain, and suddenly the exact same tool with the exact same tools available feels clumsy, gets stuck in loops, or hallucinates commands that don't exist.
It is purely because of which brain is behind the body. The harness is passing the exact same notes under the door, but the new strategist inside the room isn't as good at reading them, or writes messy notes back that the harness can't parse.
So, why does this mental model actually matter to you, the developer? It matters because it separates model hype from harness craft. When a new, ultra-powerful model drops, people think the coding agents will instantly become flawless. But a massive brain is useless if the hands are tied.
Exactly. The intelligence of the model is only half the product. If a tool fails to fix your bug, you need to know who to blame. Did the model fail to understand the code? Or did the harness fail to give it the right files in the context window? Look at both the brain and the body.
Once you start viewing your AI tools through this lens, you stop treating them like magic and start treating them like systems. You learn how to write better prompts because you know you're just adding text to a transcript that a stateless brain is going to read fresh on the next turn.
It is the foundational lens for everything else we will cover in this season. Whether we are talking about multi-agent architectures, advanced tool calling, or automated testing, it all comes back to a harness managing a brain in a jar. Let's do a quick recap. The large language model is a stateless brain. It thinks, but it has no memory and cannot act. The harness is the body. It holds the memory, enforces the rules, and actually executes the commands on your machine.
The brain and the body are separate. The model thinks and the harness acts. Keep them separate in your head, and you will be miles ahead of most developers trying to wrangle these tools.
Next time on AI 101, we are going to look closer at that nervous system. We will break down the agentic loop and show you exactly how one simple request from you can turn into a dozen invisible, automated steps before you ever see a reply.
It's where the real magic happens, or at least where the real engineering happens. We'll see you in the next episode. Let's keep figuring this out together. And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.